Okay, here goes video number 2. Good job finishing video number 1. The last part of our notes, and then we're going to do an example from your homework, is just the equation of the ellipse with a center that's not at 0, 0. So, write this down. Ellipse with center HK. And this is not that much harder. It doesn't really change anything about A, B, and C. It just changes where your vertex, or where your center is. So the equation looks like this: parentheses x minus h squared over a squared plus parentheses y minus k squared over b squared equals 1. And similarly to the ellipse with the center at 0, 0, if A is greater than B, you have a horizontally oriented ellipse, and if B is greater than A, you have a vertically oriented ellipse. And all again that means is the bigger number under your x, then it goes along the x-axis, is your bigger number under the y, and then it goes along the y-axis. Okay? Here is problem 16 from your homework. So this is again 5-3, problem number 16, and we are, 5-4. 5-4, right? Ellipses is 5-4, problem number 16. So we want to write the equation of this ellipse, and it is graphed for us, but the center is not at 0, 0. So it looks to me like the center is right there. So we can analyze this ellipse. Our center is at 1, -3. Then this appears to be horizontally oriented. So that means our equation's going to have x minus 1 squared over a number plus y minus 3. So that's y plus 3 squared over a number is equal to 1. And because it's oriented with a major axis parallel to the x, then this is where our bigger number will be. So now we just need to count. From our center we go over 1, 2, 3, 4 units. So that means this value here is 16. And our value for A is 4, and that's where we get the 16. Our value for B is 1, 2, 3, and that gives us a 9 underneath the Y value. And that's it. That's all there is to it. Okay, let's do one more example from your homework, and then we'll wrap up ellipses. So this is problem 18 on your homework. A bridge is to be built in the shape of a semi-elliptical arch and is to have a span of 136 meters. The height of the arch at a distance of 60 feet from the center is 48 meters. Find the height of the arch at its center. So our bridge, if you can kind of imagine, here's your bridge here, is going to be in the shape of an arch. So that's kind of what we're looking at here, some kind of big stone ancient bridge or something like that. Okay, so I am going to draw an ellipse with my center at 0, 0. So here is the arch for that bridge. The bridge is to be built in the shape of a semi-elliptical arch. It has a span of 136 meters. Let me go ahead and draw in my bridge here. Okay, so it has a span of 136 meters. That means this distance here is 136. 136 divided by 2 is 68, so that means this point right here is at 68,0, and this point right here is at negative 68,0. The height of the arch at a distance of 60 feet from the center is 48 meters. So if here's the center, you go away from that 60 feet, so that's about right here. The height of the arch at that point is 48 meters. So that tells you that this coordinate on your ellipse is the coordinate 60, 48. Find the height of the arch at its center. So the height of the arch at its center is this value here. Recognize that if we were to complete this arch, this is the distance from the center to the minor vertex axis point here, and that represents a distance B. So here we go. We have an equation. We need to find the equation, and then once we find the equation, that will help us figure out what B is. So our equation is going to be x squared plus y squared equals 1. The distance A is here, and that is 68. So this number here for x squared is 68 squared, which is a pretty big number. We don't know what y squared is. That is what we can just call b squared. Okay, so now this point here, 6048, is the only other piece of information that we're given. What do we do with this information? We stick it in here for the x and the y. When we do that, that's going to allow us to solve for b. Once we have solved for b, we know the answer to the question, which is what's the height of the arch at its center. So this is what that looks like. 60 squared over 68 squared plus 48 squared over b squared is equal to 1. Go to your calculator. Let me pull mine up. So 60 squared divided by 68 squared is 0.77855 plus 48 squared is 2,304 over b squared equals 1. We need to subtract this decimal from both sides. That gives us 2304 over b squared is equal to 1 minus 0.778546. Or I rounded that to 855, and that gives us 0.221454. Now we are going to multiply both sides by b squared, and then we'll divide by 0.221454. The other way to look at this that might make more sense is to just cross multiply. So if we cross multiply, I'm going to come over here. If we cross multiply, we get 2304 is equal to b squared times 0.221454. Divide by that number. Those cancel. So 2304 divided by 0.22145 is 10,403.967. That's equal to b squared. So we take the square root of that, and b is equal to 101.999. So I think it's safe to round that to 102. Was this in feet or meters? Feet. 102 feet. And that's how tall our bridge is. That is the b value, and we're done.